Hey guys, it's Chili here. Welcome back to RPG Project Twin. Today we've got a big architectural refactoring video. We're going to be refactoring the code. We're going to be adding a world class that will be encapsulating the gameplay world and all the entities separate from the game class. And we're also going to be moving some responsibility from things out of, game functions and into world and into the entity functions. Generally just improving the cohesion of our code. Let's get started. Alright, today we're going to go over a huge architectural revolution in our game engine here. So up until now, we've done it like this. Everything has been in the game. All of, the subsystems, the windows, keyboard, mouse, graphics, and all of the game entities, Chili, the background, the poos, the bullets, these guys are all in game. And then all the poo behavior is just code that is part of game's member functions. It's just all lumped up into here. Now what we're going to move towards is we're going to organize all the stuff that is in the world of our game into a world class. So you're going to have a world object, and that world object is going to contain, the chili, the poo, the bullets, and the boundaries, the background, everything like that. And that will be owned by the game. And there are two main reasons for doing this. Number one is in a real game, you're going to have more going on than just the actual core gameplay field. Like, right now we have our core gameplay field. Chili moves around, he shoots bullets, he hits poos, right? But in a game, you might have other kinds of screens, other kinds of modes. You're going to have a title screen, right? And that's going to have completely different code than the world. It should be a different class. And you're going to have, I don't know, what else would you have? Option screen. You maybe when you go to buy something at a shop, it'll come up with a shop screen interface. If you're doing a large JRPG style game, you're going to have different modes for whether you're walking around in a town or a dungeon, whether you're on the overworld, whether you're in battle mode. These are all different modes, all different screens, and they would all be different classes. So putting everything in the game is a recipe for disaster. We want to organize that all into a world class. And that's reason one, because you can switch different modes then. We could switch from the main world mode, I don't know, to a shop mode or something. Now, reason number two is right now the poo behavior is part of the game, and the chili behavior is part of the game, but I want chili and poo to own their own behavior, to be responsible for the behavior of themselves. And in order to do that, chili and poo are going to have to be aware of the world. They're going to have to be able to see the world. So I'm going to basically have to pass them a reference to a world object, and then they can query into that and get information and act accordingly. But I don't like if everything was just in game, I'd have to pass them the entire game, but they're only interested in the part of the game that is the world that they live in. So I would want to minimize things, create a world object that only contains things that they're interested in, and then I can just pass them the minimum that they are required to know about. And this kind of refactoring here, this was inevitable. This was going to happen. This is the way I believe, many, if not most games are going to do it. And but I didn't start off this way because I wanted to show you guys the process of this refactoring. Many simple games you might start on practice, they might start off like this, and eventually you're going to want to move to a better organization. And I just wanted to show you that process. So let's get down to it. Now, the actual code to implement this shouldn't be too complicated. I mean, we're basically just doing the same thing we were doing before. We're just reorganizing it, right? So I created a world class, and it has a bunch of functions here. Function for handle input, for update, for draw, and this one is an interface function for the entities to spawn bullets into the world. So these ones correspond to stuff basically that is in our game, right? Update and handle input correspond to stuff in our update model, and draw corresponds to compose frame, right? And we just pass in the things that the world needs to do those things. So for handle input, we need keyboard and mouse input. For the update of the world, we need the delta time. For the draw, we need the graphics. It's pretty simple. And here we've got all the things that we need for the game. We got the boundaries, we got the backgrounds, and chili, the poos, the bullets, everything is in here. And then in world.cp, we're just basically moving all the stuff from game into the world, into places where it goes. The main difference here is the explicit separation between input handling and updating, which I think is a useful distinction to make in your code. Obviously, game.h and game.cpp are going to get a lot leaner now because all that functionality is taken out, and it basically boils down to what do we got here. So in update model, we call handle input, and then we call update, and then in compose frame, we call world.draw. Now remember I said I wanted the entities chili and poo to be responsible for their own behavior, because I want more code cohesion. So I want the things that should be together to be in the same place in the code. More encapsulation and code cohesion there. But the problem with this is that for that to happen, poos have to be aware of the world. But the world also has to be aware of poo, because it owns poo. So we've got a circular dependency going on here. And that is always a recipe for disaster. Now, there is a good way of solving this problem, but I want to show you the not so good way first of all. The good way involves inheritance, by the way, and I haven't covered that yet in intermediate. So the not so good way of resolving the circular dependency, I've already shown it to you in beginner, I believe 21. So you can go back to that video if you want to review. But we separate poo into header file and CPP file. So by separating into header and CPP, then in the header file, we don't actually have to do anything about the world in here. So we can just forward declare the world in here, and then in the CPP file, we can actually use it. And then the circular dependency will be broken. If you don't understand how that works, again, go to beginner 21 and watch it. So after separating into CPP and header file, then we make it so that the poo takes care of its own shit. So here in poo.h, I've added a function, process logic, and this is where it makes its decisions. Basically, it's the AI processing function. And it takes a reference to the world. Notice the class here, I'm forward declaring the reference because this header file can't include world, because world.h already includes poo.h. So here we do the forward declaration, and then in update, we also pass in a reference to the world. And I added a function set direction for the poo. I'm not sure why. Maybe that'll become a little more apparent later on. Now in poo.cpp, so poo process logic, this takes all that logic for the figuring out the direction that the poo should be moving in, takes that out of world, puts that into here. So now it gets a reference to the world, and it's going to get the poos out of the world. So let's look into world.h for a second, because we've added a whole bunch of interface functions that the entities are going to be using. So they've got functions here to get constant references to the vectors of the entities. So they can get anyone with a reference to the world, even a const reference, can read all of the poos, can read the chili, can read all the bullets, and can read the boundary. So here in poo.cpp in process logic, we're reading all the poos, and we are processing to avoid clumping up with the other poos, and then we're going to read the chili, and we're going to use that to get the direction that we should move in if we're not avoiding other poos. Then in poo.update, we do what we were doing before, except for one change. We also adjust ourselves to the boundary. So now the world does not have to adjust us, we can adjust ourselves. Here's just a little minor fix that I noticed. I mentioned this already before, but in the codex here, what we were doing before is we were calling binary find function I created. And then if it didn't exist, we were doing lower bound to find the place where it should be inserted to keep the vector of entries sorted. So what I realized was that's a waste of time. I could just call lower bound to start with. And then if the lower bound isn't the one we're looking for, we can use that index to figure out where we should put the new thing. So this made the code a lot smaller. You can see a lot got erased here, and a lot sexier. This commit, just a little bit of OCD, don't need to worry about that. This one, I'm just splitting chili into header and source files. It's a bit of a chore, but it has to be done. Not very interesting, we're not going to look at it. Now here is where we basically make chili take charge of his own physics and everything, but I fucking just noticed here I've mislabeled it. I said poo takes charge of its control and more of its physics. That's bullshit. This is all about chili, so a little bit of slander there, but whatever. So we go into chili.h, and we see that I've changed set direction now. I've added a handle input function because it is going to be handling the user input and acting accordingly. So it takes keyboard, mouse, and reference to the world with, again, forward declaration, update, reference to the world. Private, we have set direction and process bullet. So I think some of these might have existed before, maybe not, but either way, I've made some helper functions here. Only Chili can use them. They're not accessible to the outside world. And a little bit of member data. Well, maybe we'll talk about this in a second here. So in chili.cpp, we include mouse, keyboard, and most importantly, the world in here. And now we've got to do our handle input, and most of this is just basically copy and paste from the stuff that we had in world, the logic that was originally in game.cpp. So here, we handle the mouse input, we handle the keyboard input, and then we set the direction of the chili. Nothing really mind blowing up in here. So what else do we change in here? Well, process bullet is that helper function, and I guess that is being called, where is that being called? It's not being called in here. So in here, all we do is we set up the parameters for spawning a bullet. We set the position, we set the direction, and we set a flag saying we are firing. So this handle input is processing the logic. It is basically queuing up a command to fire a bullet, but it doesn't actually fire the bullet. That happens during the update. So just a little extra separation of church and state here. In this function here, I only want to make decisions about what I'm going to do. I don't want to change any state of the world. And in update is where I want to change the world state. So for process bullet, what we do is we check if we're firing. If we are firing, we clear that flag and we spawn a bullet in the world. And then in chili.update, we update our position. We adjust ourselves to the boundary of the world. We process a bullet. We update our animation. And we also update the damage effect controller of Chili. So this function is only responsible for basically processing physics and changing the physics state of our character. And this one is only responsible about reading the world, reading the input, and making decisions based on that. And that's gonna about do it for today. If you enjoyed the video on this stuff, stay tuned, because once I start using the concepts of inheritance and virtual functions, then we're really gonna see some interesting architectural patterns take fold. And that's gonna about do it for today. If you enjoyed this video, this talk on architectural stuff, stay tuned, because in the future, when I start using the concepts of virtual functions and inheritance, then we're really gonna see some interesting architectural patterns unfold. But until then, thanks for watching. Hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more RPG Project Twin.